This is the second video on the April 6th assignment for intermediate algebra. First part is 10.3, 31 through 46, and then 61 through 68. Now, we are breaking down radicals on the first part of this assignment. You always need the greatest root or square root, cube root, whatever root that goes into your number. You want the greatest root that goes in evenly. 31, the problem is square root of 32, which comes out to 4 square root of 2. 32 we do together. Square root of 27, I find the largest square root that goes into 27. The largest perfect square. The largest perfect square that goes into 27 is 9. 9 times 3 is 27. Then the square root of that 9 is 3. 3 square root of 3. Number 33 is a cube root of 192. So you find the largest cube root that goes into 192. Number 34, cube root of 108. I find the largest number that you can take the cube root of that goes into 108. The largest number that I can take the cube root of that goes evenly into 108 is 27. 27 times 4 is 108. Cube root of 27 is 3, because 3 times 3 times 3 is 27. So here's my answer. 35 is another square root. 5 is not inside the radical, square root of 75. 36, 3 square root of 8. We need to break down the square root if we can. We find the largest perfect square that goes into 8, which is 4. I can take the square root of 4, and so 4 times 2 is 8. So I've broken down my 8. Then the square root of 4 is 2. That gets rid of the radical. So now I have 3 times 2, square root of 2, and 3 times 2 is 6, square root of 2. Then 37, square root of 34. The answer is shown there. 38, square root of 20. Since it's square root, I'll find the largest number that I can take the square root of that goes into 20. 4 goes into 20 5 times, and I can take the square root of 4. That's the biggest number I can take the square root of that goes into 20. So square root of 4 is 2. 2 square root of 5. Then 39, we will also break down a variable 2 with an exponent. 39, the square root of 100, x to the 5th, comes out with this answer, 10x squared, square root of x. 40 shows you how to do 39. Square root of 64, y to the 9th. Square root of 64 is 8. Square root of y to the 9th, you've got an exponent. On an exponent, 9, you divide by the index out here, 2. 2 doesn't go into 9 evenly, but 2 goes into 8 evenly. So we break it down to y to the 8th times y. I break down y to the 9th to y to the 8th times y. Then the square root of y to the 8th is y to the 4th. I had trouble writing there. 8 y to the 4th. And then this square root is left over. Remember, on an exponent, you divide the exponent 8 by the index 2. Then I got out of order here. I'll go to the next page in 41. 41 is the cube root of 16, y to the 7th, comes out to 2y squared, cube root of 2y. 42, cube root of 64, y to the 9th. Okay, cube root of 64, 4, because 4 times 4 times 4 is 64. Cube root of y to the 9th, I can do because 3 goes into 9 evenly, y cubed. Then back to 43. 4th root of a to the 7th, a to the 8th, b to the 7th comes out to a squared, b to the 1st, and then the 4th root of b cubed. 44, 5th root of 32, z to the 12th. Okay, so the 5th root of 32 is 2. Now, z to the 12th, my 5 does not go into 12 evenly, so I take it down. 5 doesn't go into 11, 5 doesn't, then the next number after that, below that is 10. 5 does go into 10 evenly, so z squared, and then I was left over with z squared. You know, it took z to the 10th times z squared to get to the z to the 12th I had. So the 5th root of z to the 10th is z squared, because 5 into 10, 2. Then left over with 5 square root of 5, the 5th root of z squared, giving us this answer. 45, okay, square root of y to the 5th, and it comes out to y, and y squared, excuse me, square root of y squared, square root of y. Cube root of y to the 5th, 3 does not go into 5 evenly, so 3 doesn't go into 4 evenly. 3 does go into 3 evenly. 3 and 2 give you 5. Cube root of y cubed is y to the 1st, and that leaves us with cube root of y squared left here. That is our answer. On 61, square root of 14 over square root of 7, division, comes out to square root of 2. 62, square root of 45 over square root of 9 is square root of 5. When you have two square roots divided, as long as they're the same root as in square roots, divide always first. 9 into 45 is 5, so square root of 5. 63, cube root of 24 over cube root of 3 comes out to 2. Number 64, cube root of 10 over cube root of 2, both are cube roots. Divide 2 into 10. First thing you do, gives you cube root of 5. Number 65, 5, not in a radical, times the 4th root of 48 over the 4th root of 3 comes out to 10. 66, 7 times the 4th root of 162 over the 4th root of 2. These two here are both 4th roots. Divide 2 into 162 is 81. So we get 7 times the 4th root of 81. 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So 7 times 3, 21 is our answer. Final two on this exercise. Square root of x to the 5th, y cubed over square root of xy comes out to x squared, y. Then 68, a to the 7th, b to the 6th over a cubed, b squared. We divide first. Now we're dealing with exponents. Remember, on exponents, you subtract exponents when you're dividing. 7 minus 3, a to the 4th. 6 minus 2 is 4, so b to the 4th. Then I take the square root of what's in the radical. This is a 2 out here on the index. 2 into 4 is a squared. 2 into 4 on the b to the 4th is 2, so b squared. A squared, b squared. That concludes this section.